Okay, this is lesson 1.5, more exact values, and that's exactly what we're going to do. We already learned about exact values in the last lesson. If you don't feel like you understood that very well, you might want to go back and rewatch the video. Definitely come in for tutoring. Hopefully you'll get what you need in class though. As you can tell just by looking on these notes, they're a little bit more complicated, although the basics of what we learned in exact values is all you really need to be able to do this. Okay, one thing that I want to make clear, and this has to do with last lesson and this lesson, is that you should be doing this without the use of a calculator. In the next lesson, we're going to learn how to use the calculator to find approximate values. You also should not be using your unit circle. Unit circle is a reference tool, but it does not. You'll not be able to use it on a test or a quiz. In the end, the ultimate goal here is to be able to do these things without a unit circle. However, there are some tools that you can use to help you along as you're doing this. For example, you might want to draw your 30, 60, 90 triangle or 45, 45, 90 triangle, your all students take calculus, or the OIO chart. Those are all things that might be beneficial as you're going through this process, having those on a separate sheet of paper off to the side and use as a reference. Again, I'm not providing those things on a test or a quiz, but you are more than welcome to put them at the top of your test or quiz. Those are all things you can produce on your own. Okay, one thing to clear up before we start this lesson is to clarify when you're squaring a trig function. The notation that you will almost always see is that when we're squaring sine, cosine, tangent, or any of the reciprocals, you'll see the squared symbol between the sine or whatever trig function it is and your degree or your radian. This means the same thing as sine of 60 squared. It's not that the reason we write it this way is so that it's clear that you're not squaring the 60, but you're squaring the entire thing. Okay? So it says, therefore, sine squared 60 degrees, or you may hear this as sine of 60 squared, although it means the whole thing squared. Since sine of 60 is square root of 3 over 2, we square that and we get 3/4. If you have the exact values from 30, 60, 45 memorized, this lesson is going to be a lot easier for you. If you don't, just refer back to your triangles. Okay, so let's look at example 1. It says 5 cosine of 10 pi over 3 minus 3 sine of 19 pi over 6. So obviously this is in radians, and what we need to do is just take this one step at a time. First, we need to figure out, well, what is cosine of 10 pi over 3? Well, what's the reference angle of 10 pi over 3? Even if you're not sure what quadrant this is, you should be thinking, oh, that's a 60-degree reference angle. Okay? In terms of what quadrant this is, hopefully this is easier for you, but again, if you think of 10/3 in terms of a mixed number, this would be 3 1/3, which would put you in quadrant 3. So I'm going to put both of these things below it as part of the process. Okay, so what I'm doing when I'm finding cosine of 10 pi over 3, and this is just a quick review of last lesson, is we're trying to find cosine of 60 degrees, all right, which is the same thing as 1/2, and in the third quadrant, cosine is negative. So cosine is 60 degrees, 1/2, third quadrant negative, therefore cosine of 10 pi over 3 is negative 1/2. And since there's a constant of 5 being multiplied, I'm going to put that in as well. So we have 5 times negative 1/2. All right, now we're going to do the next part. We're going to say negative 3 or minus 3 times what we get for the second part. So sine of 19 pi over 6. Again, you need to identify what the reference angle is. Since this is in over 6, this is a 30-degree reference angle. And 19 over 6, if you change that into a mixed number and place this on your quadrant, you'll find that this is also in quadrant 3, which makes this a negative as well. Sine of 30, negative 1/2. Okay, from here, this is a very simple arithmetic that you should have been able to do for years. Again, you should be able to do this without a calculator. So 5 times negative 1/2, negative 5/2. Negative 3 times negative 1/2 is positive 3/2. And so we're kind of lucked out here. We already got the common denominator. That will happen a lot just naturally as you go through these problems. And so negative 5 plus 3 is negative 2. And negative 2/2 is negative 1. That is my final answer. Now there is a way to check these in the calculator. I'll address that in the next lesson. Alright, let's look at example 2. Very similar type problem, although I'm going to kind of remind you of how to solve exact values when you're dealing with a negative angle. Still, when you're doing these problems, identify your reference angle, okay, and identify what quadrant you're in. Okay, you're in quadrant 3. Now, in this case, it's kind of nice because we've got negative 3 pi over 4, so there's really only one reference angle in one quadrant you need to identify. Cosine of 45, if you remember from last lesson, is 1 over root 2, or simplified root 2 over 2. In the third quadrant, cosine's negative, so we have 5 times negative root 2 over 2. And then our sine is the same thing, a 45-degree cosine and sine are the same. Also in the third quadrant, sine is negative, so we have negative root 2 over 2. Okay, so let's simplify the arithmetic here. So 5 times negative root 2 would just be negative 5 root 2. And again, this is over 2. And then this plus negative, I'm going to change to minus root 2 over 2. I can combine the numerators since they're like terms. They both have a root 2. That would give us a negative 6 root 2 over 2. In this case, we can simplify even further because 6 over 2 is 3. So our final answer becomes negative 3 root 2. So what I want you to notice about both of the answers here, and for the first problem it did turn out to be an integer. The second problem we had a radical, but these are exact answers. They're not approximating decimals, which is what you would do when you use a calculator. Alright, if you haven't bought in to memorizing those exact values of 30, 60, and 45 in your OIO chart, you need to get on board with that. Notice how much easier these problems were by not having to draw a triangle every single time. Okay, problem 3. Cosecant squared 2 pi over 3. So I want to remind you what this is asking you to do is to find cosecant of 2 pi over 3 and then square that. Same thing here with tangent. It's asking you to find tangent of 7 pi over 6 and then square it. Okay, so let's do that. So 2 pi over 3, this is going to be a 60-degree reference angle because of the over 3. This is just in the first revolution, so it should be pretty obvious that we're dealing with quadrant 2 here. And since this is cosecant, we really need to think about sine. So what is sine of 60? Okay, sine of 60 is square root of 3 over 2. So cosecant would be 2 over root 3. Now, I'm not going to worry about simplifying this just yet, and you'll see soon why that is. All right. The other thing you need to consider is whether this is positive or negative. Now, using our All Students Take Calculus chart, sine in the second quadrant is positive. However, if you miss that, it actually doesn't matter in this particular problem because we're going to square it. So if you had missed the negative, when we squared it, it would have become positive, and that's fine. So I want you to see here that we did not need to simplify 2 over root 3 before I square it, because by squaring it, I will deal with the radical anyway. All right. However, you could simplify this radical and then square it. You're just doing more work if that's what you do. All right, tangent of 7 pi over 6. All right, we've got an over 6, which means we've got a 30-degree reference angle, and this is in the third quadrant. Okay, so either using your triangle or hopefully, eventually, by memory, what is tangent of 30? Okay, tangent of 30 is square root of 3 over 3. and then we are going to square it. Again, if you just completely missed the negative here, it would have been okay. In this case, we didn't even need the negative because in the third quadrant tangent is positive anyway. All right, but the square would have taken care of that oversight if it had occurred. All right, let's square these fractions. Remember, when you're squaring fractions, you square the numerator, so 2 squared is 4. And then in squaring the denominator, like I said earlier, it's not going to become a radical anymore. 4/3. All right, plus. Again, over here, square root of 3 squared becomes just 3, and 3 squared becomes 9. Now, I need to get a common denominator here, and if you're just looking at the denominators, you might think, oh, that needs to be 9. All right, but if you just look at it a little bit closer, 3/9 is 1/3, and then I have a common denominator already. All right, so be clever about your fraction work here. Don't do more work than you need to. Then 4/3 plus 1/3 becomes 5/3, and again, this is an exact answer. Notice that it's not a decimal that has to be rounded. Okay, next problem. We've got a division, so I'm going to remind you of how to divide fractions in just a second. Though first step, just like everything else, is we need to find the reference angle. So sine of 11 pi over 6, that's a 30-degree reference angle. And what quadrant is 11 pi over 6? This should be getting easier for you. It's in quadrant 4, which means that we're going to have a negative. All right, sine of 30 is 1/2, but in the fourth quadrant, we have a negative 1/2. Okay, and I'm going to put a big division just to distinguish between the fraction and the division. All right. Cosine of negative 2 pi over 3. Over 3 tells us that we're dealing with a 60-degree reference angle, okay? And then negative 2/3 pi. You know, positive 2/3 would end up in the second quadrant, but when we go the other direction for a negative, we end up in the third quadrant, which means that cosine will be negative, okay? So we've got a negative down here, and then we got to remember, well, what is cosine of 60? If you need to look at your triangle, do that. Easier to do from memory if you have them memorized. And in this case, this is a very easy division to do. Okay? That would just be 1 because it is a number divided by itself. But just let me remind you that if in general you had A over B divided by x over y, this would be the same thing as a over b times the reciprocal of the denominator, y over x, which would simplify in this case to ay over bx, and these numbers could be integers, radicals, whatever. Okay, and another problem similar to 4, you might not luck out like how we did here. You're going to have to do the actual division of the fraction. Alright, let's move on to example 5. Okay, on example 5, we have cotangent squared 135. Now remember that this is cotangent of 135 degrees, and then we are going to square it. Alright, so next thing, tangent to the 4th power of 60. Well, we haven't seen that yet, but you could probably figure out what it means. It means tangent of 60 degrees and then to the 4th power. Alright, minus sine to the 4th of 180. I'm looking at that and I know I'm going to be using my OIO chart here. Sine of 180 degrees and then to the 4th. Bled over into this problem, we'll have to do a little bit of moving around here and make sure that every problem gets its space. Oh, that's okay. I'll use a different color for that one. Alright, cotangent of 135. Remember, on these exact values, more practice you get, the better off you're going to be. Okay? And if at any point in this you need to back it up and rewind, do that. If you find you're getting lost in this step, you need to go back and watch the 1.4 video lesson on exact values. Okay, cotangent of 135. We're back in degree mode, and anything that ends in a 5 hopefully is a 45-degree reference angle, because if it's not, we won't know how to do it. This is a 45-degree reference angle, and it's in quadrant 2. So remember that tangent of 45 is 1, okay, because of the opposite over the adjacent. This was the nice one to remember. Tangent of 45 is 1. In the second quadrant, tangent of 45 is -1. Now, flipping -1 is not too bad. It still is just -1. So we have -1 squared. Now, in this case, since we were squaring, we could have not worried so much about whether it would have been positive or negative. Right now, while I'm teaching this to you, I'm never going to skip that step, but I want you to see that if you had skipped that this was negative, it would not have affected your final answer. Alright, let's move on to tangent of 60. So this is just a straight up exact value that you should have memorized at some point. You may not have it memorized today, but you should soon. And this is square root of 3. This is in the first quadrant where everything's positive, and so we have a plus square root of 3 to the 4th power. Alright, then we have a minus. Sine of 180 degrees. This is from our OIO chart, okay? So refer back to your OIO chart from yesterday or jot it down again, and you can see that sine of 180 degrees is 0. So we have 0 to the 4th. Okay, let's think about what all of these things are. -1 squared, +1. Alright, square root of 3 to the 4th. Remember what exponents even are. It's just something times itself 4 times. I like to think of to the 4th, though, as squared squared. So square root of 3 squared would be 3, and 3 squared would be 9. And then this last part is obviously going to be 0, so my final answer is 10. Okay. I'm going to switch colors for this other problem so we don't get mixed up on what we're doing. Draw a little dividing line. Alright, 5 pi over 2, back to radians. If you're finding it hard to switch back and forth from degrees and radians, you're right with everybody else. You've just got to think about what you're given, and it will get easier with time. Alright, 5 pi over 2. What is that? Well, 4 pi over 2 would be 2 pi, so 5 pi over 2, that reference angle is actually 90 degrees, or pi over 2. Okay, it's one more revolution. If we think of it in terms of degrees, it's pi over 2 or 90 degrees. Then we get to refer back to our OIO chart. All right. Well, that means, you know, cosine of 90 degrees, if you look that up, you get 0. Okay, so this right here is 0. Now, here's the beauty of 0. Whatever you multiply to 0 turns out to be 0. So honestly, it does not matter at all what cosine of -5 pi over 4 is. For practice, though, in these notes, I am going to go through how to find this, but I want you to notice it will not matter what this is because we're going to multiply it by 0. Those are good things to make you work smarter and not necessarily harder. Okay? So this is a 45-degree reference angle. Right? It's in quadrant 2. We're going in the negative direction. Okay, this would be a little bit past pi in the negative direction, which puts us in quadrant 2, which means that we have a negative. Okay, so cosine of 45, but negative would be negative root 2 over 2. Alright, like I said though a second ago, doesn't matter. It's when we multiply it here in a second, we're going to get 0. Alright, minus. Okay, negative pi. That seems weird, but it's actually pretty simple. Think about negative pi going in the negative direction halfway around the circle. It really is just the same thing as pi in terms of when you're taking sine, cosine, tangent, whatever. Okay? So what is sine pi, or sine of 180 degrees, according to your OIO chart? Right, that's also 0. Okay, so when I multiply it to the next part, again, it does not matter at all what we get for the next part because I'm going to be multiplying it by 0. But just to be thorough in this lesson, let's go ahead and do this just for practice sake. 45 degrees, first quadrant, so we got positive, and sine of 45 is square root of 2 over 2. Okay, so 0 times whatever is 0, and again, 0. 0 minus 0 is 0. And in the future, when you come across problems like this, you should be able to just pick out the zeros and say, you know your answer is 0 without doing a lot more work. And that's how you work smarter instead of harder. Make sure you write down any questions, even if it has to do with last lessons. These are the things we're going to discuss at the beginning of each class. I expect you to come with questions if you have them. Write them down on your notes, write them down on another sheet of paper, or if you are on Edline, you can email me, or you can just email me from your email site. And as long as you get that in to me, you know, before midnight the night before school starts the next day, I'll make sure to address those in class if you don't feel comfortable asking it. All right, that's it.